Hey guys, so let's look at this equation. If we're asked to find where does y is equal to e to the x cosine x have a horizontal tangent. So first let's talk about what a horizontal tangent is, and then we'll come back to doing this actual problem. So let's say you have a graph and it looks something like this. If your graph looks like this, your equation is y is equal to, let's call this 3 on our y-axis. Y is equal to 3, right? Because you do not have when x is, let's say when x is 1, x is 2, x is 3, x is 4, it doesn't matter. Your y is always going to be equal to 3 as you go along the x-axis. So for these problems, your slope is equal to, sorry, I don't know why I said 2. Your slope is equal to 0. Your slope for these problems is equal to 0 because if we're looking at our slope form, we have y is equal to mx plus b. We do not have an mx, and m is your slope, and we don't have an x for this. We only have our b, which is our y-intercept. So when we're looking at these problems, our slope is equal to 0. And this would be considered a horizontal tangent. And so when we are looking at this in terms of a derivative, when we are looking at an instantaneous rate in time, we're looking at an instantaneous point, what you're doing is for a horizontal tangent, if your slope is equal to 0, you're looking at for the points in the line where your slope is equal to 0. So you're going to have a 0 slope with a derivative. When you have a minimum value or a max, because what's happening is that there is a point in time when you go from positive, 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 positive to negative, 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 you are having a change. And so during this change, your slope becomes 0. Same thing with having a minimum value because you're going from negative, negative, negative to positive, positive, positive. And then if you were to take an instantaneous point here, if you're going to take a tangent line that's going to touch on have this instantaneous rate of change, your instantaneous rate of change at this point is equal to 0. So your f of x, your derivative, is going to be equal to 0. So basically, this is just kind of showing how it looks graphically. You're going to have a 0 slope when you have a min or a max, or a horizontal line at some point on your original graph, your original function. And so what that's saying is when you have that 0 point, if you were to look at your derivative, you'd be crossing 0 on your x-axis if you were to do the derivative of this line. And so when you have a horizontal tangent, your derivative is equal to 0 because your slope of your original function is equal to 0. So your derivative is equal to 0. So if we need to find a horizontal tangent and you're given an equation of a line, what you're going to do is you're going to take the derivative of that equation and you set it equal to 0. So this is just to kind of show you guys what exactly we're talking about with horizontal tangents and these problems. And so now going back here, we have y is equal to e to the x times cosine x. I am not going to graph this because that would be a lot of extra work when all I really need to do for this problem is take my derivative. So I want to find my y prime of y is equal to e to the x times cosine x, and then set equal to 0 and solve. And then this is going to give me my horizontal tangent. So y is equal to e to the x cosine x. So I have a function times a function. when I have a function times a function, I'm going to have to use the product rule. And the product rule says that if I have two equations, let's call this f and let's call this g. If I have f times g for the derivative, is going to be the derivative of f times g plus f times the derivative of g. And so now rewriting this, I have y is equal to, and so my derivative is going to be equal to the derivative of e to the x times cosine x plus e to the x times the derivative of cosine x. So let's do a little sidebar here and take my derivatives on the side. So I know that if I'm taking the derivative of e to the x, this is just equal to e to the x, and then the derivative of cosine x is equal to negative sine x. So now I can plug that in, and I have my y prime is equal to, so I have e to the x cosine x, because I took the derivative of e to the x, which is e to the x, times my cosine x. Nothing changes for the second part of the equation. And then adding e to the x times the derivative of cosine x, which is negative sine x. I'm going to rewrite that as y is equal to e to the x cosine x minus e to the x sine x. And so now that I have this part of the equation, what I'm going to do is I'm going to set this equal to 0. So my y prime equal to 0 gives my horizontal tangent. And that is what we are trying to find in this problem. We're trying to find our horizontal tangent. So we're going to set e to the x cosine x minus e to the x sine x equal to 0. I can add e to the x sine x to the other side. So I'm going to have e to the x cosine x is equal to e to the x sine x, because I just added e to the x sine x to both sides. And that obviously cancels out. And so now I can divide both sides by e to the x. And now I have cosine x is equal to sine x. Let's divide both sides by cosine x. So cosine x over cosine x is equal to 1. So I have 1 is equal to sine x over cosine x, but using my trig identities, sine x over cosine x is equal to tangent of x. So now what I have is that 1 is equal to tangent x. So now to solve for x, I can take x is equal to inverse tan of 1, which is equal to, plugging this into my calculator, make sure it's on radian mode, is equal to pi over 4. But you have to write your answer in periods. So this is equal to x is equal to pi over 4, meaning that you're going to have a horizontal tangent at pi when x is equal to pi over 4. But you can't just write pi over 4. You have to add the period to this. So then you're going to add n pi to represent that if you were going to add a period of pi to this, it's still it's the same thing as having pi over 4, just because you're moving through periods on your trig graphs. So always add this n pi to represent the period that you're moving through. And this is how you would find your horizontal tangent. So you have a horizontal tangent when x is equal to pi over 4 plus the period of your trig graph, which is n pi.